Okay, good morning, everybody. Hope you guys are doing well. Today, I am going to go over section 4, which involves solving one-step equations. So, in this section, it says in an equation, the variable represents the number that satisfies the equation. To solve an equation means to find the value of the variable that makes the equation true. You will only need to perform one step in order to solve one-step equations. That's why they're called one-step equations. The strategy for getting the variable by itself involves using opposite operations. So let's take a look at this first one. It says solve each equation. So we have negative 2 equals k minus 14. First thing I like to do is draw a line down from the equal sign wherever it is. That line represents the equal sign. And so anytime you do something to one side of the equation, you need to make sure you do it to the other side so that equation remains balanced. So you can see, I'm going to highlight the variable. The variable is k. And what is happening to the k? Well, that k is being subtracted by 14. So we need to undo that subtraction by 14 by adding 14 to both sides like this. And so when I do that, you can see negative 14 plus 14 crosses out. That's exactly what we want to accomplish with these. We want the variable to be by itself. So now we're only left with a k because the 14s go away. Now on this side, we have negative 2 plus 14, which turns into 12. And there's your final answer. Now, we could check this. In order to check it, you would take this number that we found for k and substitute it back in. So in this case, we'd have negative 2 equals 12 minus 14. From there, we would subtract 12 minus 14 and we get negative 2 equals negative 2. And you can see that we end up with a true statement, negative 2 equals negative 2, which means our original answer that we got here was correct. All right, moving on to the next one. We have x divided by negative 7 equals 15. So for this one, we again need to take stock. What is happening to the variable? In this case, the variable is being divided by negative 7. And so your goal is always to undo what is happening to the variable. So in this case, the variable is being divided by negative 7. We're going to multiply both sides by negative 7. And you can see I'm marking times negative 7 on both sides. That step needs to be shown in your work, that what you're doing to both sides of the equation. So now on the left, negative 7 times x over negative 7, the negative 7's cancel. They go away, and we're just left with an x over here. Now on this side, we have a 15 times negative 7. So a positive times a negative is going to be a negative, and then we have the quick way to do 15 times 7 is to do 10 times 7, which is 70, and then 5 times 7, which is 35, and then add those two, and you get 105. So there is your final answer, negative 105. To double check, if we take negative 105, we divide by negative 7 equals 15, and you can see this, that works. 7 goes into 10 once with the remainder of 3. 7 goes into 35 5 times. Okay, the last one for today. Again, these are called one-step equations because it only requires one step to get the variable by itself. So looking at this one, we have 3/4 u equals negative 24. Now, this 3/4 right there is actually multiplying u. So technically, you would say, all right, we're multiplying 3/4, we're going to divide by 3/4. So if I had to do u 3/4 u divided by 3/4, that presents a problem because we don't ever actually divide by fractions. We multiply by their reciprocals. If you remember from the other day, keep, change, flip. So what we're actually going to do in here is we're going to multiply both sides by the reciprocal of the fraction that is multiplying the variable. So as you can see now, I put a 4/3 on both sides of the equation. So the 4 here and the 4 here cancel, the 3 here and the 3 here cancel, and we're just left with u. Now on the right-hand side, we have -24 times 4/3. In order to multiply that, the -24 needs to be put over 1 first, and then you can proceed to multiply numerator times numerator, denominator times denominator. The one thing that I would note is I would reduce on the diagonal first before you multiply because it'll make it easier. It'll actually give you the reduced answer so you don't have to reduce later. So looking at the numerators, I'm going to highlight this number and this number are the numerators. So -24 and 3. 24 and 3 are both divisible by 3. So we're going to divide both of those. 3 divided by 3 is 1, and -24 divided by 3 is -8. So I reduced on the diagonal first. Now looking at the diagonal this way, 1 and 4, those both, there's no number that will divide into both of those. So those ones are good. So now we can multiply straight across. -8 times 4 is -32. And on the bottom, we're left with 1 times 1, which is 1. So you don't need to write that. So our final answer is u equals -32. Now to double check our work, you can take the original equation, 3/4, write in -32 equals -24, like this. And we're going to multiply 3/4 times -32. So we're going to make this -32 over 1. We are going to look on the diagonals. You can see right here, this -32 and 4, those are both divisible by 4. So 4 divided by 4 is 1. 32 divided by 4 is 8. And so we're left with a 1 on the bottom of that first fraction and an 8 on the top. And from there, we can multiply straight across. 3 times 8 is 24. On the bottom, you see it's 1 times 1. Um, so it doesn't matter. You can leave it like that. I did forget to mention it was -32 in that second fraction. So when we divide it by 4, it becomes -8. So you actually have 3 times -8, which is -24. And on the right-hand side, you can see it's -24. And so since those both work, that means our check worked and we did everything correct. All right, guys, I would like you to complete the next few problems in section 4. Have a good day.